Hello, my name's Steve Smith and I'm an automotive application specialist here at Pico Technology. Now, one of the questions that comes up time and time again is parasitic drain. How do we measure parasitic drain, the challenges within, and for how long can we measure parasitic drain? Using the current clamp, obviously that introduces a number of variables like drift. Using Picoscope is another one because we've got a maximum record time of almost 14 hours, which is great. But that would involve then, if we wanted to add buffers, saving to buffer, we can automatically do that. But what about if there was a software program that would allow us to just plot trends over time, over infinite time? Well, we've got PicoLog. So thanks to the software engineers, they've actually made PicoLog work with automotive scopes. So what we're going to do today is introduce you to PicoLog, how we set up a 4425A for parasitic drain measurements using the current clamp, but also using a 0.1 ohm resistor. So we use a resistor as a shunt to capture and calculate current. And why not? We've got a BNC plus temperature transducer. Let's add that into the mix. So we've got, or we will have, battery voltage, we'll have current via a shunt, we'll have current via a current clamp, and temperature via a BNC plus probe. So PicoLog connections then using 4425A. So channel A here is going to be ×1 test lead. It will connect to the battery positive and it will also connect to battery negative. I want to leave this off just for a moment. Next up is channel B, which is going to be our shunt. So what we have here is a 0.1 ohm resistor and we'll connect that to battery negative and then also to battery negative lead. So you see that that is in series now with the battery negative lead. So any current now that passes through or returns to the battery is going to come via the lead, of course, through the 0.1 ohm resistor back to battery negative terminal. Now we've connected here, we can put the channel A ground lead onto the negative pole. So channel A is going to measure battery voltage. Channel B, we're going to measure across the resistor. So here's our ground for channel B, and it is important that that does go onto the negative terminal. And then here is our signal wire for channel B. So hopefully you can see there now that channel B is measuring across the 0.1 ohm resistor. And in our resistor, we also have a fuse for protection. Now, ideally, it would be the correct procedure to measure between this point and this point, so we measure the volt drop purely across the resistor. Admittedly, there will be minuscule resistance in here in the fuse, but on this occasion we can say that's negligible. Having said that, make sure that the fuse is a genuine one because, as we all know, not all fuses are made equal. All right, we've got the BNC plus 60 amp current clamp, which at some point we will put on the lead. That will just capture current flow. So in effect, we're going to measure current flow twice, one with the shunt and one with the current clamp. We'll be able to see the differences between those. And then not essential, we've also got the BNC plus temperature probe because we'll be able to monitor temperature. I could just slide that underneath the battery carrier and that is sufficient. So just to recap, channel A is now going to measure battery voltage. Channel B is going to measure the voltage drop across a 0.1 ohm resistor, and we'll use maths then to calculate current. Channel C, current clamp, why not? And channel D, temperature. There's our connections. Okay, so download PicoLog from picoauto.com, so picoauto.com downloads, and we'll launch PicoLog. And the first thing that we need to do is connect. So you'll recognize here that the software has detected a 4425A and the serial number as well. So the first thing we need to do is configure the scope. So channel A, remember, was connected across the battery. So we are 20 volt range, which is fine. It's a 12 volt battery. And look at the sample interval, 1 sample every second. We can go to millisecond, but for parasitic drain, we'll keep it at a second. So we'll add that channel. So that channel is now configured. Channel B, that's slightly different. We are measuring voltage, but we're measuring it across a 0.1 ohm resistor. So we'll go to the advanced options here and we go to probe or scaling. and we're going to use an equation. So first of all, the input is millivolts. Let's place that in brackets. So millivolts divided by 1000 will give us volts. Volts divided by 0.10, which is our resistor, will give us current. So the input is millivolts, divide by 1000 for voltage, then divided voltage by resistance will give us current. Now the return units, they are going to be amps. We save again. Let's just run through again. Channel B, we're going to have it as red. Change colour if you really want to. One sample every second. Sample mode is average. We're using an equation. The input range, let's dial this down a little bit. Let's go to something like 5 volt, because that would be a lot of voltage drop across that resistor, which is why we have the fuse there. And we'll add the channel. Notice in the top corner now, we are milliamps rather than voltage. Channel C, it's already recognised that it's a current clamp because it's BNC plus. It did say 0 the clamp on save. Now the clamp is not connected at the moment. So now we can go ahead and connect the clamp. We can connect the clamp to the lead. Now channel D, it's already recognised it's a BNC plus temperature probe, so no configuration there, and add the channel. And we should see now our temperature, there we are, and current workshop temperature is 17 degrees, or temperature of the battery I should say. So there we are now configured. Battery voltage is quite low, which is interesting. We wouldn't normally start parasitic drain measurements with that value, but for the purpose of demonstration we'll run with it. The current shunt is measuring around about 14 milliamps. Current clamp is around about 0, give or take. Next then is we can start recording. So here we have the start recording button. So we press start recording. Now then, this is where Pico Cloud comes into its own, a PicoLog. So there's two options. There's a local capture or there's a cloud capture. So we'll give this file a name. So we'll just call it parasitic. Parasitic test. Continue. Now I'm already logged in, so there's a couple of options here. You can log in with your Google credentials if you have them already, or maybe Facebook. Another way is to create your own account, your PicoLog account. We'll go with stop after fixed time. So we'll go, let's keep this running for a couple of days. So PicoLog is going to stop capture after 2 days. Continue. So capture summary. It's a cloud capture. The beauty of that is we can all log in and see how this is going, this capture. Stop capture after 2 days, and it's called a parasitic test. Start capture. Notice now that the recording is flashing here, so we know that we are capturing data. Here's our values, our numerical values, and here's the all-important graph. So if we just click on here, this will give us an option to show all data, which is where we are. We could be following the new data, and we can also auto scale y-axis if required. I've chosen to show all data. They're all on one axis at the moment, so there is a means to change this. So we'll go with y-axis, we'll go for 4. And now we can configure, so we'll keep channel A on axis 1. We can drag channel B down to axis 2. This is using my touchpad with gloves. There we are. Channel C on axis 3. There we are. Channel D on axis 4. There we go. So they're all running on their own axis. And that's pretty much it. A couple of things to be aware of with PicoLog, of course. Make sure the laptop power settings are set to continue to record so they won't shut down when the laptop has been left dormant. Laptop powered by mains. We're going to leave this on for 2 days. I think that pretty much covers everything. We can log in, which we'll discuss later, but for now we'll leave this recording and we'll join this vehicle in a couple of days' time to see just the parasitic drain level, changes in temperature, and how the current clamp compares against the resistor. Thanks again. Okay, there we are, 2 days of logging, one haircut later. Let's have a look at the data that we've captured and look at how the battery voltage has changed, the relationship between the current from the current clamp and the shunt, and because we can, let's have a look at temperature too. So with the Picoscope stop, we've got the time and date across the bottom there, so we'll see the 2 days of logging. And using the cursor button here, let's just have a look at battery voltage. So if we start around about here, remember we started with quite low voltage anyway, so we were at, I think it was 11.98. Battery voltage has dropped over time, over that 2-day period. Now, is that in any way linked to current? Well, let's just have a look at current from the current shunt, and that was minimal. Let me just put my glasses on so I can qualify this. We are at 6.89 milliamp for the entire duration. Looking at the current clamp, there we are at 118.216 milliamp, and there we have the difference between using a current clamp and using the shunt, because there we're having to handle drift over time. Notice at these points here where the current increased momentarily, I think it went up there, if we just put the cursor on that one, 2.25 amp. That was because door open, so during that point it was a case of opening the door just to see the current change. Really more of a test to recognise that the shunt and the current clamp are working accordingly. 2.2 there, and I think 1.7, maybe a little bit more, 1.8. So yeah, there we have it. Just be aware of using current clamps for these prolonged tests. Parasitic drain over 2-3 hours is fine with a current clamp once you've followed the procedure, allow the clamp to warm, etc. But certainly any prolonged logging really has to be a shunt. I think we can safely say here we need to recharge this battery, and the fact that it's discharging on its own, that's good enough evidence for me that we need to replace the battery. Finally, just look at the temperature. We can plot this over time, of course. Highest temperature recorded there on day 1, almost 20 degrees, and then on day 2, a bit warmer, just over 20 degrees. Not always necessary for parasitic drain, but because you've got a spare channel, and if you've got the BNC Plus Temperature Pro, well, attach that to the battery. Certainly gives you an indication of conditions throughout the monitoring. So there you have it. That is PicoLog for that 2-day process. Parasitic drain, perfect tool. A neat feature in PicoLog is alarms. So if we're looking at parasitic drain, let's say we've got 2.25 amp there. Typically, we're always looking to keep that parasitic drain as low as possible. Remember, that was door open, as was this here. So it might help to set a threshold or an alarm so that you're notified that the current has gone high. So we can use the alarm feature here, and we can add an alarm. Now, there's a couple of options here. We've got a threshold, so a trigger when a channel leaves a specified range. Channel disconnected could be quite useful as well in case inadvertently something's become detached, or a custom expression. But we'll go with this one, threshold, and we'll go channel B. And we want to be notified when our parasitic drain increases above, let's say 2.5 amp. And we'll hold off for a few seconds. So we'll go for 5 seconds, because remember, you may have spikes from certain systems, and we're also sampling one sample every second. So certainly after 5 seconds, if that current is still high, we want to be notified. So we save, and there it is. There's our summary. So that when channel B threshold increases above 2.5 amps for 5 seconds, we'll be notified with the sound. Over and above parasitic drain, PicoLog's got some really neat features that we can go through and discuss, and especially 8 channels. So here we've got multiple scopes connected, 2 4-channel scopes that we can link together through PicoLog. So we can now log continually 8 channels. And then Pico Cloud as well. So whilst the data is saving, we can actually generate a link so we can get to the Pico Cloud and monitor remotely how our logging is doing. So if we think back to parasitic drain, it might be that you just want to check in to make sure everything's okay, there hasn't been a power outage or anything like that, so the laptop has failed. Yeah, use PicoLog. We'll go through that process now. So here's our configuration for 2 scopes. So we'll see we've got 2 4425As connected, and we've configured them as we did before. So every one I've just set to 20 volts and given each one the same color as they would be if it were an 8-channel scope that's connected. So here I'll start the record button, and notice now we've got 2 options. You've got local capture, which is the machine, or let's click on cloud capture. So we'll give this a name. We'll call it 2 scopes. Click continue. I'm already logged in, by the way, using my Google credentials, but you can actually create an account and log in, or you can actually use other credentials like Hotmail. We'll stop after a fixed time. That's what we're going to go for, and we'll just go for 1 hour logging. Now the maximum logging is 30 days at 1 sample per second for 8 channels. So if you are using the cloud, those are the limitations. We'll continue, and we'll start the capture. And of course, if we now go to our graph view, at the moment we are on just 1 axis there. So we've got voltage on the 1 channel only, and everything else is on the same axis. Now we can do like we did with parasitic drain and choose multiple axis, and then we can drag accordingly. So we can maybe put, let's put C down here. We'll just grab them at random, D. So we've got a couple going there. And now if I wanted to dip in here and share, so this is our capture that's going at the moment, 2 scopes. So I've clicked on the cloud icon here, click here, and then enable sharing link. So now if we copy this link and then forward that to our own email, forward it to a colleague, whoever then clicks on the link will be returned to the logging screen. So this is what they'll see. Now they can't make any amendments to the capture at all. It's just purely to view the capture. So some of the features within PicoLog, you've got your cursor here, of course. So depending on which axis you're on is the value that will be displayed by the rulers. We've got something nice here called annotations, so we can add an annotation, and it might be at that peak there. I'll just put spike and then add, and then that will appear. It could be door open, something like that, or power out, power on. You've got your zoom functions here, zoom in, zoom out, and your pan. So panning, of course, would be dragging across. And here then you've got how you want to view the data. So it may be that we show all data as we do here, or follow the new data, and auto scale. Okay, so typically it'll be show all data. And then as before, we can leave that running accordingly, check in. Let's also, let's pause the capture and have a look at options here. So we've got save data or save configuration, and then export features as well, how you'd like to export that as CSV maybe, if you're using other software to make additional calculations, HDF5 to clipboard, and then as an image. Okay, so there we have it. There's some real neat features in PicoLog. It's very slow, remember, it's 1 sample per second. I know you can go to a millisecond. It's worth experimenting with, I guess, but for parasitic drain, it certainly works. Hopefully you've seen there a couple of new features. So the multiple scopes is quite cool. It's very cool, actually. And as is Pico Cloud. So I hope it helps. I can see a number of applications, automotive and off-highway as well. Enjoy.